Welcome back to AK App Logics. In the previous class, we have discussed about the architecture declaration. Okay. In the last two classes, we have discussed about the VHDL programming. VHDL program is basically divided into two parts. One is entity and another is architecture. Basically, it's divided into two parts. Means it's not separate. Okay. Both the combination of those two parts. We will get the VHDL programming. Okay. In that, we have seen about the entity. Entity is where we are going to declare input output and generic constants we are going to declare in entity, whereas in architecture we are going to mention the behavior, describe the behavior of the inputs and outputs, or the relationship between the input and output. Okay, so in that we use some concurrent statements. Okay, these concurrent statements can be specified in three types. Those things three different ways. Okay, those thing is called as the levels of abstraction. In the levels of abstractions we have three types. One is behavioral model, and then data flow model, and then the structural model. Today in this class we are going to learn about the behavioral model in very detailed manner. Okay, so without any delay, let's move into the video. Yeah, let me take orange. Yeah, so levels of abstraction in that first type is behavioral model. Okay, we write the VHDL program based on the truth table. Okay, based on the truth table we are going to write the VHDL program. Okay, based on the truth table of the design. For example, if you are going to the half header, we are going to take the half header truth table, and then we are going to write the code for the half header using this truth table in the architecture, right? Yeah, next example. Yeah, we are going to take the full adder. Okay, this is the full adder which is having the three input ports, namely A, B, C in, and then two output ports, namely sum and C out. These things will be specified in the entity, right? Yeah, so this is the truth table of the full adder. Okay, truth table is basically the relationship between the inputs and the outputs. Okay, in the input side we are going to take the all the possible combinations of the inputs. Here we are having total three input ports. It means the total input combination that we are going to have is 2 power 3, that is equal to 8, right? So these are the values from 000 to 111. Okay, by applying these values 000 to 111, we are going to see what is the output of sum and cout. Okay, the table which is formed by this is called the truth table. Based on this truth table we are going to write the code, or we are going to describe the relationship between the inputs and outputs in the code. That model is called as the behavioral model. Okay, let's see the example code. So first of all we are going to take the entity, right? Any code any VHDL code is made up of the two parts, that is entity and another is architecture, right? First of all, in the entity we are going to specify what are the inputs and output ports. Entity, after I taken that entity name as full adder FA, and is a keyword. Okay, I haven't mentioned, I forgot to mention is a keyword. Entity full adder FA is, in that entity we are going to mention what we are going to mention: generic constants, port declarations, and then entity declarative items. In this particular program it doesn't require any generic constants. Okay, the generic constant is an optional, right? If we required, then only we need to use it. Okay, so that I'm going to the port class, so that I have used the port keyword and open the parenthesis. In that I have mentioned inputs. What are the inputs we are having? We are having total three inputs. Those are A comma B comma C in. Okay, all these are input ports, so that we are going to specify them in the same line by separating them with the comma and then colon in. It is the type of in. Okay, you can use capital letters or small letters, anything you can use, because VHDL is a case insensitive programming language. And then I have mentioned the type, subtype indication, which is the STD logic. You can use STD logic, or you can use bit, or you can use bit vector. Okay, anything you can use based on your requirement. And then I have mentioned the semicolon. After that I am going to mention the two output ports, those are sum and cout, and I am mentioning those two output ports in the same line itself. with the separating the by separating them with the comma, and then colon, and then out. Okay, the mode is out, right? And then the type is std logic. After specifying std logic, I haven't used any semicolon. Why? Because it's the last port, right, that I am going to mention. So that for the last one we have to specify the closed parenthesis followed by the semicolon. Okay, and then after writing the port, we don't have any declarative entity declarative items as well, so that we are going to end the entity. How we need to end the entity means, we simply use the end keyword followed by the full header, that is entity name, right? Full header, and then we need to use the semicolon. Okay, when you are going to see in the Verilog, you are not going to use any semicolon at the end when you are going to specify the end module, but in the case of VHDL you need to use the semicolon. And then till this part our entity is completed. Okay, till this part our entity is completed. Okay, our entity is completed. So after that we are need to specify the architecture for this entity. Okay, for this entity only we need to write the architecture. Okay, in the entity what we have going to specify is inputs and outputs. Those things I have specified over here. Now we are going to write the logic in behavioral model. Okay, architecture is the keyword, we need to use it, and behavioral is the architecture name. It's the architecture name, right? Of, we need to use the of is the keyword, and we need to specify the entity name for which entity we are going to write the abstract architecture. For that particular entity name we need to mention, and then is a keyword. After that we need to use the begin keyword. uh, in that begin only we are going to write the concurrent statements or the logic between the logic relation between the inputs and outputs. Okay, in the behavioral model you need to use the process statement. Okay, you need to use the process statement, it is mandatory in the behavioral model. And in that process statement you need to specify what are the inputs of the design in the parenthesis. Okay, this is the point you need to remember. And after specifying the process you need to again begin. Okay, you need to again begin, and then we are going to use the if else statements. Okay, if else statements for this case of the full header, we are starting the if and parenthesis a equal to quotation single quotation 0. Okay, a equal to single quotation 0. It means whenever the input a is 0, and is a operator, right? And is a operator, so we are need to specify the and. Then only whenever the both the conditions are applied. Okay, if we are going to use or here, any one of them applied, we will get the output, but we need to see the both the outputs, right? So that we need to specify the and only, we shouldn't specify or. And b is equal to quotation single quotation 0, and cin is equal to single quotation 0, close the parenthesis, then is a keyword. Then what happens if this is the case for the half header? For our half header, okay, sorry, for our full header, if we are going to apply a as 0 and b as 0 and cin as 0, whatever, then what should happen? Then what output should we need to get? We need to get the 0 and 0, sum as 0 and carry out also as 0. Okay, this is how we know this point means, this point we know from the truth table, right? In the previously we have seen, right? Let me show you. See, whenever the all the three inputs are 0, then we are going to get the uh, both sum and carry out as 0. So this particular condition is specified using the if, right? We have specified this condition using the if, and the next condition you need to use the elif, else if. Okay, else if we are going to use. Okay, else if. Okay, similarly all these up to last one we are going to use the else if only, okay, to specify the condition. Okay, for the last one we are going to use the else. Okay, for the last one we are going to use the else, like we are going to use in the C programming language. Okay, so let me show you. See, this is the first combination of the input and the what are the output that we need to get. We have specified the behavior or the relationship between the inputs and output using the behavioral model. Whereas for the second input, second type of combination of input, that is A equal to 0 and let me change my pen color. That is A equal to 0, B equal to 0 and then Cin is equal to 1. Then we need to get the sum as 1 and the carry as 0, right? So that thing we have specified here, but we have used the else if, right? Why? Because previously we have used if and then we need to use the else if. Similarly, we need to use the then keyword, and after this we need to use again else if, again else if, again else if, till the last condition. For the last condition we need to use the else condition. Okay, else. Okay, after that you have begin the if, right? We have begin the if, so that you need to end the if. Okay, and you also started a process, right? So you need to end the process. Okay, both and if are the keywords, and both and process is also a keyword, and you have started the architecture, right? Architecture behavior of FA. You need to end this architecture as well, so that end architecture name. What is the architecture name? That is behavioral, right? So you need to specify it. Okay, so what we have done is, initially we have written an entity for the full header. Okay, for the full header, which specifies the inputs and output ports using the port class. Okay, after that we are going to write the architecture for the entity. After that we have written the architecture to the entity of the full header. For that only we have specified that behavioral of FA. What is this FA indicates is the entity. For this above entity we are going to write the architecture. We are going to write the architecture. Okay, and the point you need to remember is we need to use the process block or statement, anything you can able to say it. We need to use the process while we are going to discuss with the behavioral model. In that process we have taken again begin. Okay, before process we have taken begin, and also after process we have to specify begin, and then we have specified our logic using the if else statement. Okay, and then we have entered the if statement, and also we have entered the process, and then later we have entered the architecture which we have created. So this is the code in the behavioral model for the full adder. So all the inputs that are need to be specified in the process statement or the block while writing code in behavioral model. This is the point you need to remember while writing the code in the behavioral model. So that's it for the video. In the coming next video we are going to discuss about the how to write the code in the data flow model that we are going to discuss. Thank you.